Hi everyone, and welcome back to another episode of Dr. Guard Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going through the required practical in where we investigate the variables that affect the temperature changes in reacting solutions. Now this is for trilogy and triple, higher and foundation. So without further ado, please give the video a thumbs up, check out my TikTok channel and Instagram, grab a pen, grab a paper, and let's go ahead and jump in. Okay, so some key info really quickly. First of all then, we have got exothermic reactions release energy to the surroundings. Endothermic reactions take in energy from the surroundings. Exothermic reactions include combustion, many oxidation and neutralization reactions. And then endothermic reactions include thermal decomposition and the reaction between citric acid and sodium hydrogen carbonate. So this is your required practical that you need to know. It's a little bit different to other required practicals in that it can be asked in several different ways. So what kind of a reaction could this be? So it could be the reaction between different volumes of acid and alkali. It could be the reaction between different masses of metal and an acid. And it could be the reaction between different masses of metal oxide or a carbonate. Now, there could be other ways they ask this as well. What is always going to be common here is they are going to ask you to measure the temperature change. And so your dependent variable for all of these, the one you measure, is going to be your temperature for every single one. Just like so. Okay, so what is important then? Because you're investigating the variables, they will give you different reactions in which you need to be able to identify what those variables are. But because we know it's a temperature change investigation, there's your big clue straight away. So reaction between different volumes of acid. So your independent variable is the one you change, and so that's going to be your volume of acid. And then your control variable is going to be your volume of alkali and your concentration of acid and alkali. So for example, this could be hydrochloric acid and sodium hydroxide, which is going to be the example that I go through in a minute. Or it could be the reaction between sulfuric acid and potassium hydroxide. And here you would just change what you need to do, measure your temperature, and keep the concentrations and the volume of whichever one you're putting in your polystyrene cup the same, which we'll go through the method in a second. Okay, so reaction between different masses of metal and acid. So your independent variable here is going to be your mass of metal. Your dependent variable again is your temperature, and then your control variable here is going to be your volume of acid slash concentration again. So you want to keep that the same. Reaction between different masses of metal oxide. So here your independent variable, this could either be a metal oxide, so it could be sodium oxide, or it could be sodium carbonate, depending on what's going to happen. So it's going to be a metal oxide mass and your or slash carbonate. So again, it could be potassium carbonate. And so they're going to be different reactions that they give you, but the key thing here is always going to be your temperature change. And so here your control variables, again, is going to be your volume of acid, and your concentration again. Just going to write concentration down there like that. So I've just given this slide here essentially for you to understand that you can't just learn one method off by heart for this. It's a good idea to go through one and have a really good understanding of it. But when you go into your exam, you need to be able to read that question really carefully and go, right, this is a temperature change method it's asking me for. There's a few things that are going to be really key, like using a polystyrene cup, stirring the solution, measuring the highest temperature change, that kind of thing. But I'm going to have to potentially use 1 gram of metal each time, or I'm going to have to change my volume of my acid, or I'm going to have to use a different concentration of my acid, or a different metal oxide each time. So there's different ways they could ask this practical. Okay, so your method then. Let's look at the example where we take sodium hydroxide and HCl together, and we're going to measure the energy changes when you add different amounts of sodium hydroxide to your acid. So here then, we would measure out 25 centimeters cubed of volume of HCl into a polystyrene cup. Now this is really important. This is your first clue. They might even write this in the question. If it's talking about a polystyrene cup is an insulator, and that keeps in the energy for this reaction. So we use polystyrene cups because it's keeping in the energy, and we want to measure that energy. Using a thermometer, measure and record the initial temperature of the acid. And I just want to point out here as well, 25 centimeters cubed of acid, not super important. It could be 10 centimeters or 15 centimeters, as long as you keep it the same every time. So we're going to measure the initial temperature, because then when we get a final temperature, we can then take the initial away from the final and work out our energy change. So we're going to measure out 5 centimeters cubed of NaOH and pour it into the cup. We're going to stir the solution and use the thermometer to measure and record the highest temperature. And so now we've done this, we can then do highest, take away initial, and that will give you your change. Okay. Now, again, why do you wait for the highest temperature? You want to essentially do your reaction and then let that thermometer go all the way up. And when it stops, that's when you know the reaction is finished and complete, and then you can then move on to your next measurement. You don't just want to stick your thermometer in quickly and then look at the reading and then move on. You want to wait until it reaches the highest point. Okay. Then we're going to keep adding HCl in 5 centimeter cubed increments and measure and record the temperature. Record the results. Again, highest temperature there if you want to be really specific. Record results in a table and you plot a graph. So here then, independent variable is the volume of NaOH. That's what you're going to be changing. Your dependent variable is the temperature of the solution. Control variables, concentration of HCl and NaOH, and also we could also put in the volume of HCl as well. So here then, what we would have is we would have temperature up the side here. So remember, your dependent variable is what goes on your y-axis, and your independent variable, the one you're changing, always goes on your x-axis. So here it was volume of NaOH. So let's just think about what's going on here. You had a polystyrene cup, because you're measuring your energy changes, and you had 25 centimeters cubed, or we had 25 centimeters cubed of HCl, and we were adding in 5 centimeters cubed of NaOH each time. So let's have a think what's going on then. So we add in our volume is increasing along our x-axis, and our temperature is increasing along our y-axis. So we add in, say, 5 centimeters cubed of NaOH, it's going to be 0 there. And then we're going to add in 5 centimeter cubed of NaOH, and we record that temperature. So let's say that was, roughly there. Okay. We add in another 5 centimeters cubed of NaOH, and the temperature increases because that reaction is still carrying on. We add another 5 centimeters in, the temperature increases again, still carries on. Now, can we see each time you add 5 centimeters cubed NaOH, it's reacting because it's an exothermic reaction, so it's going to be giving off more and more heat energy. However, what's going to happen is eventually you're going to get to a point where the temperature kind of either plateaus or it's going to start to go down. And so what you might have to do in the test is put in 2 kind of lines of best fit here, where you would kind of go, and apologies that my line's not going to be particularly straight here because I'm on a computer. You would go straight through like that, and you would go straight through like that. And so here, just there, is your point of neutralization. And what you need to understand here is that as you are increasing the volume of NaOH, the temperature is increasing. Hopefully we can see that nice and easily on the graph. But eventually the reaction stops because there is no more HCl to react with, and so you've neutralized everything. And so now all you are doing, even though you're adding more sodium hydroxide, you're basically adding in more sodium hydroxide into the solution, and so any kind of remaining energy or remaining heat, I should say, that's in that solution is then going to go into that additional 5 centimeters cubed of NaOH each time. And so then the temperature starts to drop. So the temperature then starts to dissipate into more of that solution that you're adding. And so the HCl has been used up. It's now a limiting reactant. The energy and the heat then starts to dissipate, so the temperature then starts to go down. And so anytime you see this kind of graph where you've got 2 lines of best fit to put on, you just draw one up, one across, cross them over, and then the point in which they cross over is going to be the point of neutralization in the example of NaOH and HCl. Now again, this could be adding in a different mass of metal each time. Or it could even be that you have 4 different metals and you want to find out what's the most reactive. So you're going to use a polystyrene cup to add the metal into an acid and then measure the highest temperature point, and whichever the one is the most reactive is going to give the highest temperature reading. And so anytime they ask you to measure the energy, you use your polystyrene cup, you stir your solution, you measure the initial temperature, your highest temperature, and you follow that method through for your independent, dependent and control variables. Thank you very much for watching. Please do go through from my other GCSE videos for more GCSE science help. And remember, if you ever need help with your GCSE science, Dr. Kyle explains. Thanks very much. Bye-bye.